Imagine stepping out of your spaceship, taking a long, deep breath, and realizing you're not wearing a spacesuit. If you trust the movies, you'd expect your body to violently explode the second it touches the vacuum of space. But the reality is much quieter. Because there is zero atmospheric pressure out there, the immediate threat comes from the inside. The gases naturally trapped inside your body begin to rapidly expand. If you panic and try to hold your breath, that expanding gas has nowhere to go. Your lungs will violently rupture. As you see in this biological timeline, it takes exactly 15 seconds for completely deoxygenated blood to travel from your lungs up to your brain. Once it hits, you simply pass out in a silent loss of consciousness. If the empty void between worlds is this instantly lethal, it exposes a terrifying gradient. Earth is a rare anomaly.
The other planets in our solar system are a compounding series of environmental horrors that will quickly extinguish human biology. We start our tour on Mercury. Sitting so close to the sun and lacking a heat-trapping atmosphere, the surface is heavily cratered and exposed. If you step onto the day side, you are hit by a blinding wall of sunlight, driving temperatures up to 800 degrees Fahrenheit. At that heat, the water inside your skin and blood vaporizes immediately. But if you take a few steps over to the night side, the environment violently flips. With no atmospheric blanket to distribute the heat, the temperature plunges to minus 290 degrees, freezing a human body solid in seconds. Moving one orbit outward brings us to Venus. This is arguably the most hostile destination in the inner solar system, trapped beneath a dense atmosphere of carbon dioxide and corrosive sulfuric acid clouds. This diagram illustrates the crushing reality of Venus's surface. The atmosphere pressure here is 65 to 90 times greater than on Earth, which is the exact equivalent of standing 3,000 feet deep in our ocean. Under that immense weight, your lungs would collapse instantly, and because the runaway greenhouse effect traps heat at a melting 800 degrees, your body would incinerate at the exact same moment your skeletal structure is crushed. On these inner rocky worlds, suffocation is an afterthought. The total lack of temperature regulation or the staggering weight of the air itself destroys your structural integrity before you even realize you can't breathe. Skipping past Earth, we reach Mars. Despite the popular dreams of colonization, this dusty landscape is actually a freezing, highly irradiated desert. Mars has a remarkably thin atmosphere, measuring right around 7 millibars. That is less than 1% of the pressure we experience at sea level, pushing us across a deadly biological threshold called the Armstrong limit. Looking at this thermodynamic chart, you can see what happens as atmospheric pressure approaches zero. The boiling point of water drops below 98.6 degrees. Through ebulism, the moisture on your tongue, the fluid in your lungs, and eventually your blood will literally boil. Arriving at Jupiter, the nature of your death drastically changes. There is no solid rock to die on here, only a bottomless, terrifying freefall. As you approach, Jupiter's incredibly powerful magnetic field subjects you to intense radiation belts. Your central nervous system would fry before you even breached the upper cloud deck. If you somehow kept falling, the atmospheric pressure would continuously compound. Millions of pounds of pressure per square inch eventually compress the surrounding hydrogen gas into a dense metallic liquid ocean, compacting your body into the planet itself. Crossing into the outer solar system, you no longer freeze or boil on a rocky surface. Instead, you are slowly dissolved and crushed by the heavy, hostile chemistry of the gas giants. Next is Saturn. Like Jupiter, it lacks a solid surface, but it introduces a severe aerodynamic threat hidden beneath its serene rings. Space probe data reveals that winds whipping across Saturn's equator reach 1,100 miles per hour. As you fall, you are battered by supersonic storms moving faster than a bullet. Moving further out into the deep freeze, Uranus offers a highly concentrated atmosphere of hydrogen sulfide, the exact same chemical that gives rotten eggs their smell. Beneath that toxic gas lies an icy, slushy mantle, setting at a frigid minus 288 degrees. Finally, we reach Neptune, a planet that combines the worst features of this outer neighborhood. You are subjected to a deep freeze of minus 330 degrees, all while being torn apart by the fastest winds in the solar system, clocked at a supersonic 1,200 miles per hour.
Out here at the darkest edges of our planetary system, biology is simply erased by sheer kinetic force and absolute unyielding cold. Let's pull back from the freezing winds and the crushing depths, sweeping past the gas giants and the boiling rock, to stop right here. This is our home. Human biology requires an incredibly precise set of conditions to operate. We need stable atmospheric pressure to keep our blood liquid, requiring a specific blend of breathable air and the exact right distance from the sun to avoid freezing or vaporizing. The rest of the universe is violently hostile to life. This little blue marble is a statistical miracle, acting as a truly rare cosmic oasis in an otherwise lethal void. It definitely puts our daily complaints into perspective. Which of these planetary environments do you think offers the absolute worst way to go? Let me know your thoughts in the comments below. Make sure to hit subscribe, and I'll see you in the next video.